But for those who don't know me, my name is Don Davis, and I am technology evangelist at this place, Rainbird. So tonight I'm going to be talking to you about Philosophers, knowledge, and children's television programs, which has caused quite a few people to go. It is a fairly esoteric title, and there is, I assure you, method to my madness. So let's plough on. Does anyone know who this is?
James Joyce when he was younger.
No. It's from after then. No one?
That's a bit hard.
This is Bertrand Arthur William Russell, 3rd Earl of Russell, Order of Merit, Fellow of the Royal Society, philosopher, logician, mathematician, historian, social critic, and political activist. He's had considerable influence on a lot of different fields, including logic, mathematics, set theory, linguistics, artificial intelligence, cognitive science, computer science, philosophy, including philosophy of language, and something I can't even pronounce, and metaphysics. So he is what you would call a bit of an overachiever. He's also the foundation for a lot of what I do during my day job, so I'm eternally grateful to this guy. This one's slightly harder. Anyone know who this is?
It's Professor Apple.
Slightly easier. It's Professor Yaffle. He's a character from Bagpuss, for those who don't know, which is a children's television programme. Which originally aired before I was born. Despite the fact that it's sort of 40 years old, Bagpuss is actually regarded as one of the quintessential children's television programmes of the UK. I think it was 2005, it was voted in the top 100, at the top of the top 100 in fact. And most people remember the main character Bagpuss. Less people remember some of the other characters like the mice and Professor Yaffle. And the ornithologists among us, who knows what this is?
Kookaburra?
It's European green woodpecker, which is Picus viridis from the family Picadea. There's 4 subspecies that occur in parts of Europe and Asia. And the European green woodpecker doesn't, like most woodpeckers, rap against trees. It spends a lot of its time on the floor eating ants. They're known for their particularly loud calls to attract attention. It's also a fairly random slide to have in a technology talk. But then again, this talk hasn't exactly been linear thus far anyway, so I mean, why break a habit? But if we had a tiny little bit of knowledge that we find buried at the bottom of Wikipedia, we find out that the European green woodpecker has a common folk name, and that is Yaffle. And in fact, Professor Yaffle is based on the European green woodpecker. And if we take a little bit more digging around in Wikipedia, which I spent a lot of this weekend doing, you will find out that Professor Yaffle is in fact based not just on the green woodpecker, but on this guy. The dry academic persona is based on Bertrand Russell. One of the creators of Bagpuss actually met him before Bagpuss was made. So why do we care? Well, can anyone guess what one of the other names for the green European woodpecker was? And I think I've heard it over here. But in case anyone can't guess, I'll give you a small hint. It is actually also known as a rainbird. And basically, given this set of knowledge, we can infer that Rainbird is named after Bertrand Russell, albeit in a slightly convoluted fashion. Now, as a human, it's quite easy to make that leap. You can follow the steps and go, okay, yes, fine, company name comes from the fact that this guy was in Bagpuss and the associations therein. For a computer to work that out is actually incredibly hard. So we're going to take a slightly toy example. Who remembers the game Guess Who?
Yeah.
Yes. For those who don't know, Guess Who is a 2-player game, and you start off at the beginning with a bunch of cards all face up, and you take a random card, and then you try and guess what the opponent's card is, and you do this by asking a series of questions about the opponent's card. Is it female? Do they wear glasses? What colour's their hair? Various things like that. The object of the game is to be the first to find out who the other person's card is, and you do this by basically eliminating everyone down to the last card. So what I'm going to need now is a volunteer. Any? Can we confirm that we've never met before?
You met this morning.
So what we are going to do, this is going to be a live demo. Let's hope the internet's working. It is. Right. Do you want to select a card? Any card. And you can show it to the audience. Right, so Rainbird is going to guess which card you have. Is the person a woman?
Yes.
Does the person have blue eyes?
Yes.
Does the person wear glasses? You've got Anita. Now, this is actually a brilliant example of an inference engine. You're basically taking a whole set of data, and you're gathering some facts about that data, and you're boiling the data down to a single answer by inferring information. So we can infer that because Anita doesn't wear glasses, has blue eyes, and is a female, it's the only person who actually matches all that data. Hello? Wrong screen. It's not a technical demo if it doesn't go wrong. Cool. So, there's a number of ways we could have done this, from sort of sitting there and just iterating through the data, big table of data and doing a select, graph database and matching patterns on there. But a lot of the solutions tend to be actually fairly brittle and fairly single use. Please don't check that code, I haven't actually checked if it works. Our example system has basically just encoded a set of very, very simple data, data that's actually been thought about, so it's binary, and it's only going to come up with a single answer, and it's a lot of yes-no questions. Is it a female? Yes, no. Do they have hair? Yes, no. Unfortunately, the real world is a little bit nastier than that. Does this person have a beard? Yes. Does this person have a beard?
Almost.
Which one? The foremost person, yes. Beard? Yes? No? What about this guy? But at what point does stubble stop being stubble and start being a beard?
When it gets longer.
There's a range. And it starts to get a little bit awkward for computers to understand this kind of thing, because the whole beard, not beard. There's an element of certainty that we need to introduce. And in fact, real-world data tends not to be 100% certain about things. It tends to be very, very vague. Now, to maintain the seemingly random nature of this talk, we're going to jump to dogs, especially whether a given breed is suited to a particular household. Theory holds that certain breeds of dogs are suited to sort of like large households, large gardens, and there are other traits that perhaps make a dog more suited to your particular household. But the problem is, what's a large garden? Now, I think I've got a fairly large garden. It's one of the largest gardens on our street. But where this picture was taken, the garden is orders of magnitude larger, like they've got their own woodland. And it makes my garden look tiny, so do I have a small garden? Even if we were able to model the household perfectly that we're trying to work out who the dog's for, and if we try to model the dog breeds perfectly that we're trying to recommend for this household, there is an awful lot of subjective data coming in. Define a large garden, define a large house, define how much free time you have. So what we need to do here is we need to consider certainty about various answers that we give. So can I have another volunteer? Someone who might be looking to get a dog, who wants to know what breed of dog would be best for them? Anyone? Go on then. Up you come. Right. What breed of dog should you get? questions are a bit odd because we're still here. Do you perform, does the household, do you require a dog to perform specific tasks? Are you getting a hunting dog?
No.
Do you need to
They make coffee then.
Unfortunately not. Does it need to be in a specific cage? Yes.
What about the slider?
Ah. Are there any other children? The sliders, how sure are you? Children might count. Are you interested in a vulnerable breed of dog?
No. Non-existent.
Just small, we're not very sure. Are you flat? Flat. And where are you? Town? Town. Do you have lots of free time? Do you have an average amount of free time available?
Maybe.
Let's stick with yes and not particularly certain. This is where we find out that the live demo crashes.
We're just not allowed dogs.
It fools us into thinking it's doing something, but it's just
It's
a gift.
It's just animated CSS.
It's not a Microsoft product.
It would be nice if it showed you a filtering, like it started off with 160 and then narrowed down to 140, 100.
Chris,
I'm
you
actually
went down
wondering
this
because we
bit
gave it an unknown whether it's narrowed it down. Oh, here we are.
No.
I will tell you what's happened there.
Perhaps the cat.
You've hit a bug. What should have happened at the end is you get a picture of a dog going, we recommend that you get a whatever would have been recommended, with a certainty. At the moment, we know that there is a bug with a certainty of 100%. However, for breaking it, allow me to present you with a blankety blank checkbook and pen. You get the idea, though.
So, a serious question, Dom.
Yep.
Could you go through the answer the questions? It says at the end you shouldn't have a dog.
It can come up and say we can't recommend anything for you,
Okay.
which you can take as you should.
Sorry, what happens if you click unknown, but you're not at all sure?
You think that's bad enough? What if you say yes, but with a 0% certainty? You can have true, and you'd be 0% certain that it's true, but it's not false.
No.
At that point, you start, yeah. So, certainly allows sort of really nasty real-world data sets and results to be taken into account. And we can basically produce answers that we think might be right, which turns out is very, very useful. What we're describing is basically a type of expert system. These aren't new. They've been around since the 1970s, actually. I think in the 1960s is when they were first described. I still maintain there's nothing new in IT since 1964 at Xerox Park. I've yet to be proved wrong. Now the problem is that expert systems tend to be very, very difficult to set up and very, very expensive to write. And not only that, but knowledge is not static. Take the dogs example, for example. You've no longer got the bog standard kennel club breeds. You've now got Labradoodles and God knows what else being bred, and people are going out and wanting, so you need to add them into your knowledge base. And they're not cheap to maintain either. And to top it all, these systems are not always that great. So you've got a classic example of the dogs database, classic example of the NHS Direct, which was an online diagnostic tool. I don't know if anyone used the old version, which was the whole body. And you basically plug in your symptoms and it tells you what you should do. Unfortunately, there's a few weaknesses with this particular system. There was a huge bias towards meningitis. Stiff neck, call 999. Put in the symptoms for renal failure, and it says, contact your GP. Now, renal failure can put a real downer on your life. Yeah, if you don't actually see someone soon enough, they can do irreparable damage. The problem is basically to do with how the systems are built. And it's likely they lack the flexibility to be changed and lack the flexibility to ask the extra questions that perhaps they might need to be asked. So the meningitis example is one that's actually happened to me. You go in, you plug in the details, and it says call 999, which I thought was a little bit melodramatic. So I went to my GP and explained the symptoms to them. And the GP told me straight away I did not have meningitis. And the reason being is I lacked one vital symptom, which after 5 days was death. And to actually mention with the Leeds hospitals, my patient data will be in there, because I also had the renal failure one, where it said contact your GP, and well, basically blue lighted into hospital after the GP said no, you should have phoned an ambulance. Luckily I'm born with a funny set of kidneys, so it's effectively like I'm running grade 10 rather than the rest of you who are running grade 1, and I can handle the loss of one. I can really, really vouch for having active, high availability organs. It's great. All we need now is off-site BCP. Let's imagine that these systems aren't enormously expensive to put together, and let's imagine that they're not really hard to maintain, or let's imagine that they don't crash halfway through interrogating them. What might we do? What might we do with these things? So let's take an example that will actually benefit two medium-sized Norwich companies, possibly more. That's wine. So you may have noticed on the meetup conversation, Paul asked whether people wanted wine to be brought along, and then asked whether people wanted red or white wine, which is a fairly standard question, red or white. But what about rosé, or sparkling, or dessert wine, or fortified wine? Although you can probably make certain inferences that say we're not going to need dessert wine because we're not having dessert, and we're not going to have sparkling wine because we're cheap. We're not going to have fortified wine because we wanted to all be reasonably sober while you're watching this. But even just limiting down to red and white and possibly chucking rosé in there, you're hiding a massive amount of complexity in the knowledge. Categorising a wine as red is about as good as categorising someone as black or white. You know about their colour, great. You can make zero inference about anything else. You may have preconceived ideas, but you're probably making assumptions on data that is completely incorrect. So, fish. We all know that we have white wine with a fish dish. But which one? There's hundreds, if not thousands, of white wines out there. Red wine goes with beef, I'm told, but again, which one? Vegetarians among us? I don't know, white? Rosé? Split the difference. The truth is, this is a really complex subject. And actually matching wine to a meal with someone's tastes being taken into account is something that requires expert knowledge. Now, there are some sites out there that you can go to and go, right, I'm cooking beef, and it says, right, buy this wine, which also happens to be sold on our particular website. But they're just doing if A, then B. So if this particular ingredient's in the meal, then suggest this particular wine, which will also be the most expensive one. Having a conversation with a wine expert is something that allows more details to come in. So you can turn around and say that I'm having beef, and perhaps the wine expert would say normally you have a big full-bodied red, and you go, no, I don't like big full-bodied reds. Please suggest me something else. Or it could be that your signature dish is actually the dessert. So your wines for the previous courses, you don't want to spend too much money on them. You want to make a huge splash with the wine for the dessert to complement the fact that you're spending a lot of time on the dessert. It's something that a website generally isn't going to take into account. Perhaps you're just serving nibbles. What goes with salty nibbles? Problem is that experts cost money. Virgin Wines employs an entire team of people who you can phone up and ask questions about. I'm having this particular stuff at my dinner party. What wine should I buy? Naked Wines probably has similar. I'd actually be very surprised if they didn't. What would be great is if we could replace some of these people with an expert system. And then we can reduce the reliance on expensive experts, and we can also get customers to start self-serving. The problem is here about how do we go about capturing the knowledge that a wine expert has and presenting it in a fashion that it can ask questions of the customer sensibly. You'll notice in the dogs database, well, not dogs database, the questions were not brilliant. Do you have a large amount of time available? Then asking, do you have an average amount of time available? It's not the best way you can order things. So capturing the knowledge is actually quite difficult. It's what's known as a knowledge engineering problem. Knowledge engineering is a bit different to software engineering. With software engineering, the software bit is easy. I can take anyone and get them to write hello world in 10 minutes. It's the engineering side that's difficult. It's the writing large, robust systems that actually work in production. And it turns out that we still don't have a blind clue how to do any of that. Knowledge engineering is the other way around. The engineering bit's quite easy. Drag and drop UI that does that. Capturing the knowledge and learning the knowledge about something is difficult. You pick a subject that you're an expert about it because you spent a lot of time looking into that. Getting that knowledge into a way that you can actually present it so it's accessible is also difficult. So with knowledge engineering, it's not the engineering that's the difficult bit, it's the knowledge. Now, you may have heard the phrase, knowledge is knowing that a tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. Now you may laugh, but this is a classic example of why basically applying random rules to knowledge just doesn't work. If we take Wikipedia as a reasonable example of human knowledge, and ignore the fact that half of it's wrong, if we fed that into some large expert system, we would have something that knew an awful lot about an awful lot. They've actually tried that, and then they started asking it some questions, and it came up with the inference that all humans are famous. Which from its point of view was correct, because the only time you're going to be written about in Wikipedia is if you're famous. That particular project was actually trying to create strong AI, the I know now why you cry and it's something I can never do, before lowering itself into the vat of molten lead. That's a little bit difficult. We're not going to talk about that tonight. What we're going to do is do something a lot simpler. We're going to capture a little bit of knowledge about just why. And also a little bit about the person who needs to interact with that why. But actually, it turns out you can grab that information on the fly. You don't need to know about every single person in the known universe to build a knowledge base that will solve that problem. The key thing is basically structuring the knowledge in a way that is asking pertinent questions, going back to the guess who. Break the knowledge down very, very quickly. And in fact, with those guess who cards, there's a lot of questions you can ask but don't need to, because you've got to the answer straight away. Same with the dogs. There are some questions we probably don't need to ask up there because you can get to the answer a lot quicker. So we're going to take a very, very toy example, and this is where it all goes horribly wrong, or more wrong than it did before. And we're going to ask the question, what language does somebody speak? But we're not going to actually ask that directly. This is where I have to type language. We're not going to ask the question directly. We're going to infer it from other particular knowledge. So first of all, we've got the idea of language. There you go, language. And within that, we can put in languages. So we can turn around and say that English is a language. And we can turn around and say that French is a language that I can't spell. German is a language. And you can go through and stick every single language known to man, including Klingon, in there. Now, we're not going to ask, what does Frank speak? Because that's too easy. You can easily write a program to that. We're going to turn around and we're going to take the idea that if someone lives in a country, they are likely to speak the language of that country. So, we're talking about countries now. We can turn around with the country, and we can say, come back. The country has a national language. So we could turn around and say that England has the national language of English. Germany has the national language. And again, you can just go through and add bits. Let's just move these up a bit. So we were talking about people. So we probably need to add the concept of person. We can say that a person speaks a language and that a person lives in a country. And the last thing we're going to say is that some person speaks some language if that person lives in some country and that country has a national language that matches. And we're done. This knowledge base will now work for everyone who lives in Germany and England. And if we were to put it out, it would work for all 7 billion people in the world, despite the fact that we have no information about people. And the way this works what language speak? And we're saying the person who's provided by the user speaks some language. That's what we're trying to find out. That's the question we're asking. So we can pick any person in this particular room, or anywhere in fact. They live in England. Bank speaks English. Now, this is a very, very toy example, but what you can do is you can start improving where it's getting its data from. So you can start adding concepts for parents, language the parent speaks, country that the parent speaks, how long the particular person's been living in that country, whether they were born in that country, and you can start making very, very good guesses about the particular languages that a person may speak. And you can turn around and tell the system that a person may speak more than one language. And you can start running inference about various languages that they could perhaps speak if their parents were from a foreign country. We can then assume that perhaps they're going to learn that language too, so they're multilingual. If they've been somewhere for a short period of time, the certainty that they're going to be able to speak a language is going to go down. If they've been there all their life, the certainty that they speak a language is going to go up. There's various things that we can do, and to turn this into a fully fledged system fairly quickly. So if we return to the wine example, instead of just having the what wine should I have with a meal question, you can actually start asking much more intelligent questions about, will I actually like this particular wine that I'm about to spend 100 and something quid on? And this isn't about your traditional people who bought this, also bought this type of upsell where you're just doing a little bit of pattern matching. This is about applying some intelligence to your system. With the case of Virgin Wines, they offer a price promise. Don't like the wine? You can get your money back. And even if you send back, if you bought a case, even if you send back 11 bottles of this stuff, you've got two lots of delivery that need to be paid for by the company. So this is actually quite an appreciable effect on the bottom line, fulfilling this price promise. A much better way would be to turn around and check out before you've even dispatched the stuff and gone, no, you won't like this particular bottle of wine based on your preferences. We reckon you should actually have this bottle of wine instead. Now that's a huge leap away from what most websites do with the let's try and upsell. What we're actually doing now is saying, no, we don't think you'll like that. And you're going to help your reputation with that as well, because you're not sending out stuff that people go, ooh, I don't like the stuff from Virgin Wines, or I don't like the stuff from Naked Wines. It's actually, maybe I won't like that. Maybe I will try the suggestion. Let's take a look at another example, a little bit more tacky. Computer hardware. So let's just imagine you've just placed an order for a case, a power supply, a motherboard, some memory, hard drive, GPU, water cooling, monitor, keyboard, mouse. Basically, we can now infer that you are building a computer. Fairly high certainty that you are going to be building your own computer. But what if the water cooling kit doesn't actually fit in the case that you've got? Or what if the memory that you bought doesn't run at full speed on the motherboard that you've just bought? And in fact, in the memory case, you may never know that your memory is mismatched to your motherboard because it will work, it'll just work at a lower speed. So you may be spending extra money that you needn't spend. wouldn't it be better if the website turned around and said, actually, no, this particular configuration won't work if you're building a case or if you're building a computer. Perhaps you might want to try this. And one of the things you can do, for example, my case is very big. All the reviews said, make sure it fits under your desk. What they should have done is turn around and gone, this will not fit under your desk. 100% certain. But then also have answers about, I didn't know whether my power supply was going to have cables that were long enough. With this, you can turn around and you can say, right, your power supply won't reach. You can buy one that has cables that will reach. Or you might be able to buy a smaller case. Or we may even have extension cables. And you can start providing options to your customers for how to get out of the conundrum they've got. PC hardware is actually a field of knowledge that is changing quite rapidly. I think last month there were 34 new motherboards announced by 2 different vendors. That's 34 each. So traditionally, keeping this kind of system up to date would be very, very difficult. You can turn it into just a data entry problem with someone sitting down and entering in extra bits. Now, just like software engineering, the whole field of knowledge engineering is something that's set to become pertinent to every aspect of life. And it's going to solve a huge set of problems that are coming out. And we're beginning to see this. It's the dawn of smart software is coming. And people have problems they don't even realise that they can solve, that can actually be solved with smart software. So if you look at things like Siri, if you look at things like OK Google and Cortana, which is the Microsoft one, Cortina or something like that, I don't know. You've got these smart assistants that you can start speaking to. I know with OK Google you can start asking it questions and it knows that you've got an appointment in half an hour's time, and if you're going to be creating an appointment now, perhaps you might not be able to get between the two. There's a lot of this sort of smart software that's coming around. So yes, this domain is going to become absolutely huge. And it's something that people need to start thinking about now. Because you're going to start getting left behind by the Googles and the Apples of this world. But it's not really something that you can start turning around to your CTOs, CIOs and saying, well, we need to spend hundreds of thousands of dollars just to bring in the same technology that Google and Apple are. But it is something that you can turn around and say, well, we can apply this to our site, we can apply this to our app, we can apply this to our software for a reasonable cost. And it's something you can start looking into now. Because I reckon this is going to become a huge part of computing. So hopefully, I've given you a brief glimpse into the world of knowledge engineering and what Rainbird can do. Hopefully, more of you will come along to the Hack Day. There's a huge amount of stuff that this can do, and what we'll be doing at the Hack Day is allowing you to bring your own data, your own knowledge, and setting up your own knowledge bases. So I'm a massive gamer. One of the things I want to do there is actually start putting in details for Elite Dangerous. You've got the universe, effectively the whole galaxy. Start plugging in things about where should I go. At the moment, with only 55 stars, it's nice and achievable. When they open the game up, I'm going to need an army of slaves to enter all the data for me. The day itself is £15. That's just a token fee basically to cover the cost of the room. There's going to be refreshments, there's going to be lunch, there's going to be prizes. So if you want to speak to, where's she gone? Emily, there. Which leads me basically to say thank you very much for listening to me prattle on. Apologies that one of the demos died. Beta software. And if anyone's got any questions, give me a shout now, or grab me, or Chris who's sat at the back with the Rainbird t-shirt.
Sleep.
Have you got any questions now? Fire away.
There was a guy called Doug Leonard about 20 years ago who did some aspects of this in a system called Psych, and he had a bunch of guys called cyclists who sat there overnight putting this data in, and then kind of it ran overnight and refined it. Have you tried creating any really very large?
No, because the problem with that, the problem with the sort of going for the massive knowledge bases is how do you tie the knowledge together? What you want to do is start going for much smaller knowledge bases. One of the things I haven't covered is Rainbow can link knowledge bases together.
Does it do that using semantic web?
Yeah. So the dogs example, you've actually got a household database and a dogs database, and they're tied together. Because when you start taking too much knowledge, it starts becoming very, very difficult to present that knowledge in an effective fashion. And you tie yourself up in knots far too quickly. It would be possible to put Go into Rainbird. The knowledge required for that is massive, insofar as there aren't actually computers big enough in the universe to handle the amount of data that you need to put into the system to make it beat someone at Go. So you break it into much, much smaller domain-specific problems. It's a bit like code. You don't want methods that are yay big. You want nice, small, reusable things that you can plug in. Two questions at the back.
Does the system learn from people's answers?
Not yet, but it can do. So one of the examples that we cite with the meningitis thing. Another example is with diabetes. You're putting through, and the system may come up and say, okay, you've got diabetes, and you can turn around and go, actually, no, I haven't. I've been tested for that. So you can then you'd be able to go back and find out at what point it sort of decided that you had diabetes and discounted various other things, and you can then tweak the searches. But at the moment, no, it doesn't learn its status.
It's kind of actually semi-optional to ask. What the NHS system, where do you think it went wrong, and where do you think you're going to answer that problem?
I don't know how it was written, so I can't say for certain, but I think it basically, it was a standard system of you're taking a lot of yes-no answers, and in fact some of it isn't yes-no. With my particular renal failure problem, because I've got more than the standard number of kidneys, I wasn't on the floor dying. So some of the questions it was asking, I was sort of going, I'll err on the side of caution. Whereas if you had a much more flexible system where you could sit there and go, well, kind of, I think so, but I'm only 50% sure, you can start exploring more paths down the tree graph. So the NHS system, I think they took too much. I think they've realised this because the new system actually breaks it down into different body sections, and it goes to what I was saying to you. You've got a much more specific set of knowledge you need to worry about. And if you need to come in and ask questions about other parts of the body, for example, with meningitis, you need to start asking about the stiff neck. You can do that and bring that data in rather than taking it as part of the whole. Stiff neck could just be that you've laid down on a pillow.
Yeah, and I agree that you need a confidence value when you do an expert-based system.
Yes.
Because you cannot certain otherwise. You know, it's the 80-20 rule, isn't it, with these
Yeah.
systems? Yeah, and I'm surprised when I used the NHS. My wife at the time got the meningitis thing, and she was petrified. And it wasn't meningitis, and it shocked me that they could write a system to the public which was so kind of specific in something which they didn't give you the balance, the
Every single time
probability
I've
of the
used it,
answers.
it said ring 999. The only time it didn't was the time I got blue lighted to hospital. So.
Yeah, it's pretty shocking. Yeah.
Yes.
Are you able to say anything about the implementation? I guess it might be proprietary, but is it a prologue type system?
It's JavaScript, yay, on the front. C++ they could then Prolog in the back end. So this is basically exposing Prolog to the world. Prolog is nasty. I've seen the code. I don't know.
I wrote Prolog. Yeah,
We may want to speak to you.
It's been many years ago. Yeah, it's Edinburgh.
Yeah, the Prolog does all the magic. And then also there's a C++ layer that exposes it to Node.js, and then the whole entire web app, the entire API is Node.js. That all goes out in the cloud.
Have you tried kind of seeding the data or the knowledge with machine learning? Because it kind of looks like the opposite of big data, doesn't it? It infer a load of stuff from data and then...
The machine learning comes back from does it sort of remember answers? And so the classic example you give for the speech database is you turn around and say, okay, well, we've said that Frank speaks English, so we can just remember that fact. And maybe just check, does Frank still speak English before we go ask a lot of other questions. That's as far as
train it with a big data set, couldn't you?
you could train it with a big data set, but then you will probably actually have to have the expert data training, and you'll probably find that the expert is better suited to writing the rules and getting it to come on. Interestingly enough, the Guess Who example, despite the fact that there's an instance for every Guess Who card, it was actually better to write it with rules to get the kind of questions that we wanted to be like a Guess Who game. Rainbow tries to be a little bit too clever and just turns around and goes, okay, what hair colour is it? Rather than is it red hair? And you will find that if you think about it as a knowledge engineering problem rather than as a computer science problem, don't worry about how Rainbow's going to solve things. Just put the data in there and let it do stuff. It does some fairly funky stuff.
With that in mind, do you think that if you applied Rainbird to the WebMD problem, do you think it'd come up with better answers?
Yes. Okay, I'll finish this question. No, the reason for that is because the WebMD problem, with your traditional expert systems, you go get a fantastically expensive developer who's probably going to be a diva at the same point, and you get a fantastically expensive, knowledgeable person who's also probably going to be a diva, and you try and get those two to talk. And there's get rid of the developer, get the expert talking to the system themselves, and that's the key there, is getting the expert, getting as close to the expert as possible so they can put in the knowledge. And then, because it's so easy to tweak the rules and so easy to tweak the relationships, if it's punting out rubbish, you can just go in and say, okay, let's adjust things. If anyone wants to ask any more questions,
How long's the hacker? You answer all the questions now, no one's going to come to the hacker.
but then they can create their own things with us on hand to help you. You can redo the NHS and make millions. I mean, spend millions.